Okay, so let's go with problem 9. It's what are the concentration of H3O plus, concentration of OH negative, and POH, POH of in a solution of pH 11.60. And by the way, this is pH. So we have to do now the opposite. We're going to find first, I'll give you the step, H3O plus. Second step would be find the concentration of OH hydroxide, OH negative, and 3, find the POH. So here we're going backward because the pH is the minus log of the concentration of H3O plus. If you want to find out the concentration of H3O and you're giving the pH, the same with the POH, but a hydroxide, is 10 to the negative of the pH. And that gives us the concentration of hydronium. So let's do it. The concentration of hydronium here, because the problem is giving the pH, is 10 to the minus 1160. So the concentration of hydronium is 2.5 by 10, 2.5 by 10 to the negative 12. The concentration of OH, now with the Kw, we find the concentration of OH. And it's Kw, concentration of H3O plus, multiplied by the concentration of hydroxide. The concentration of OH negative would be equal to Kw divided by H3O plus. So the concentration of hydroxide now is going to be equal to 1.0 times 10 to the negative 14 divided by the concentration of hydronium, 2.5 by 12 to the negative 12. The concentration of OH would be now equal to 4.0. Yeah, you have to put only one decimal, 2 significant figures, because it comes from here. When you enter that on the homework answers, when you enter them in Connect, you have to do it. You're going to get your number, different from mine, but you have to do it by 10 to the negative 3. You have to put 2 because if not, you're going to get it wrong. And it comes from this, from the Kw. So the POH would be, because the problem is asking for the POH too, right? Yeah. The POH would be minus the log of 4.0 by 10 to the negative 3. So that means that the POH, okay, you put minus the log in the calculator, and then you put 4.0 by 10 to the minus the negative 3 or whatever number you got. So you put the negative on the calculator, then the log, and then they put a number. It depends on the calculator you have, but generally almost all of the scientific calculators have that. So POH would be equal to 2.40. Okay, we're going to go ahead and move to the problem 10. Okay, in problem 10, the problem is asking for what are the concentration of H3O, OH negative, and pH. Now it's the opposite. The problem is giving us the pOH. With a pOH equals to 10.95. And it's equal to, first of all, with the pOH, you know you can find the concentration of hydrogen, the same thing as we did with that. The first step is finding concentration of OH negative from pOH. Second step would be finding the hydronium concentration. This is using pOH. Using KW. And then, third one, finally, find the pH using concentration of hydronium. So let's go with the first step, step number 1. And it's the concentration of hydronium is minus the log of, I'm sorry. Uh, Okay, let's find the concentration of the hydroxide by using the pOH. And it's 10 to the negative pOH of the pOH. So the concentration of hydroxide would be equal to 10 to the minus 10.95. That seems like a basic an acidic solution. So here the concentration of OH negative would be equal to 1.12 by 10 to the 11th. 1.12 times 10 to the negative 11. So using KW is 1.0. We're going to find out the concentration of hydronium. And is a concentration of H3O plus gives me 1.0 kW by 10 to the negative 14 divided by 112 times negative 10 to the negative 11. So the concentration of Ia3O plus equals 8.9 by 10 to the negative 4. 8.9 times 10 to the negative 4. And then finally we can find the pH. And pH would be minus the log of A3O plus, which is going to be pH minus the log of 8.9 by 10 to the negative 4. So the pH would be 3.045. Those are a little bit long problems. Okay, let's do number 11. Okay, asking for both and the pOH. A3 plus OH negative and the pOH and the hydrogen concentration and the pH is given. So same thing. Find first step, the concentration of H3O plus, because they're giving the pH. So we can find concentration of hydronium by the opposite. Sorry, guys. Okay. And it's going to be equal to 10 to the minus the pH. And it's minus 5.11. And this is giving you I didn't do 11 and 12 because it was very similar. But let me finish it then. This is going to give us, the only problem is that I need the calculator here. And it's going to be second function 10 to the negative 5.11. That gives me 7.76 times 10 to the negative 6. No, I didn't do 11 and 12. And molar. So the concentration of OH negative would be, because we want pOH and this, 1.0 by 10 to the negative 14. Those are easy calculations, so I can finish it there once I started. 76 by 10 to the negative 6. So the concentration of OH negative is equal to 1.0 times negative times 10 to the negative 14 divided by 7.76 times 10 to the negative 6. It's 1.288 So it's 1.3. Let me by 10 to the negative 9. So this is going to be OH negative is going to be 1.3 times 10 to the negative 5. And this is going to be POH equals minus the log of 1.3 times 1.28 times 10 to the negative 9. POH equals there must be something wrong here. Let me do it. Oh, there's nothing wrong. It's like I'm so tired that watch, because if you have a lower pH, it's acidic with a higher with a high POH. A high pH is basic with a lower pOH. And if we get this, this is going to be minus the log, because this is pOH, that's why. Minus the log of 1.3 10 to the negative 9, 8.89. 8.89. So now, I don't want to lose time going down. Okay, here, 12 is also the same thing. So 12, do it yourself. Look, they give you the pOH now. You have to find out. Let me give you the steps. With the pOH, find concentration of hydroxide. Then 2, with the kW, you find concentration of H3O plus. And then with that, you find the pH. In 3 steps, you can do it. Let's do 13. Mm-hmm. Okay. This is the conjugate acid base pair. And it's on this one. This is I did it because this is a little bit. Well, I did it. I'm gonna explain it. And the 13 says, okay, what's the acid here? Water. Do you see water lost the hydrogen and gave it to the HS? It's the base here because it accepts the hydrogen. So H2O, remember, water connects as an acid or a base. What is the acid? Water. What is its conjugate base? Hydroxide, because the conjugate base of water, and remember, conjugate base is losing one hydrogen and then adding one negative charge. So it's OH. Here, what is the base? HS negative 1. Okay, and the conjugate acid H2S. Let's do 14. The same thing. Here, the acid. What is the acid? Nitric acid. If you look, this is donating the proton to NH3, which is the base. And NH3 is amphoteric, could be act as a base or as an acid. In this case, it's as a base. Don't forget what I'm saying. So this gives a proton to NH3 is acting as a base. So the acid would be this, and you know this is an acid. Nitric acid is a strong acid. And then what is its conjugate base? conjugate base would be NO3 negative. It's missing here. And over there it's not, but here. What is the base? In this case, the ammonia. And the conjugate acid of ammonia is one hydrogen more on the positive charge. So it's NH, it's ammonium, and it's the conjugate base and the conjugate acid of a weak base that is ammonia. So it's a strong conjugate or stronger conjugate acid. Okay, now let's go with the Ka, asking for the Ka. Very similar to the ones from the PowerPoint, this one, but it's not talking, well, it's based on pH. So if you got this is 15, 14 and jump it because it's the same thing. So 15, you get 15, 0.3, then we got HA, general acid. You don't need to even give that, but it's H2O, right? H3O plus. Let's do plus A negative. So here you go. Okay, 0.037. You don't even need the IC because the concentration of the weak acid is this one, and they're giving you the pH, and you know that the concentration of H3O plus is equal to 10 to the minus the pH. So the concentration of hydronium H3O plus equals 10 to the negative 4.83. Sorry, I was looking at the answer already. And the H3O would be equal to 1.479 by 10 to the 1.48 times 10 to the negative 5. So to find out the Ka, right, we use the expression of Ka of the constant, equilibrium constant, which is going to be the products on top, H3O plus by A negative divided by the concentration of the acid, HA. Do we have this? We have this 0.037. Do we have the concentration of hydronium? Yes. And the base, conjugate base, yes. Because you remember X, this is the same. This is, sorry, 1.48 times 10 to the negative 5. And this would be the same, 1.48 times 10 to the negative 5. And if you see, you got everything to calculate Ka. So Ka would be the concentration of both are equal. So you can put 1 point equal and equal to this. The concentration of A negative is equal to the concentration of H3O plus, which this one is 1.48 by 10 to the negative 5. You square this, divided by the concentration of the acid, which they gave us, which is 0.037. So Ka, you solve it. Ka would be 5.9 by 10 to the negative 9. So 16 and 17 are the same problem. Yes, 16 and 17 are the same. I did 17 um, this today. But I wanted to do it for a student that asked me a question, so I end up doing 17. But when I was gonna do 16, back to 16 is the same. So 16, when you get into it, you're gonna solve it like this. And it's basically hydrofluoric acid, right, plus water. Hydrofluoric acid is a weak acid, and H3O plus OH negative. The concentration, the Ka, equals 6.8 times 10 to the negative 4. Okay, and here its value seems high. The concentration of the, and by the way, yeah, this is HF. The concentration of the acid is high. And I got a type arrow here. Sorry. This is, I got a type error. So the problem is asking for the concentration of hydronium OH. Okay, they give you the Ka of the hydrofluoric acid and the OH. They're asking also for a OH. And in a solution, that's where I got the mistake. In a solution of 0.790 of HF. And you should have, okay, very similar data. That's the 17. And if you look how I do it, you can do the 16. I don't know if you can go back. I think you can go back on the homework. But, okay, the concentration here is 0. The initial 0.790 0.790. And here you got nothing, right? 0 and 0. Not yet. So that we had to do the I table. The change would be minus x plus x plus x. And equilibrium would be 0.79 minus x, x, and x. So here you got that the Ka, which is 10 to the minus 4, equals H3O plus, you know this expression already by now, OH negative divided by 0.790 minus x. Now this is kind of negative 4, but on the other hand, this concentration is high, so I am going to take the risk of dropping the x here. So the value of Ka is 6.8 times 10 to the negative 4. So 6.8 times 10 to the negative 4 equals x to the square divided by, we drop that, 0.790. That's it. So x to the square, we get the cubic root of, well, 6.8, we multiply this by 0.79 both sides, multiply by 0.790 equals x squared. Now we get the cubic root on both sides, and it's going to be this by this is 5.327, 5.372 by 10 to the negative 4 equals x. Oh, x is equal to 0.00223 m. No, not yet. Hold on. So this would be my x. Let's check if it's less than a 5%, the both terms. So you get your x and divide it by 0.790. I'm going to check if this assumption was correct. So I got x 0.023 divided by 0.790 by 100 equals, and this gave me 2.94%, which is less than a 5%. So my assumption was correct. I can drop the x. So knowing that, we know that that was the value, okay, of H3O, and the problem is asking for that. So H3O concentration equals the OH, the hydroxy, no, equals the, I have to do this, sorry. Let me put pause. I'm going to erase this. Minus is the fluoride. So the concentration of hydronium equals the concentration of fluoride. That's what the problem is asking. Do you see? And also the OH negative. But we're going to do it now. The hydroxide. And this equals to the X. Now, where do I get the hydroxide? From, like I said, the ionization of water. Kw is H3O plus. If you have an acid, doesn't tell you anything else, you know that if you find H3O plus, you can find OH always by the ionization of water. So it's going to be Kw 1.0 by 10 to the minus 14. I don't think I'm going to be asking both of them like the homework does. Divided by the concentration of H3O plus. I'll ask you for the, like this up to here. And maybe pH, POH, maybe no. But this like that, But let's do it. This is the concentration of OH negative. So the concentration of hydroxide is equal to 1.0 times 10 to the negative 14 divided by the concentration of hydronium, and it gives me 4.3. Remember, 1 decimal, 1 by 10 to the negative 13. Another part, finish for now, and then we'll continue.